right, so we're looking at section 4.4, and we've addressed this idea a little bit already, but we want to focus in today on this concept of the reference angle. We're going to look at what the reference angle is, how to find the reference angle, and then what the significance of it is. Okay. And then we're going to do a bit of practice together, just using it and also doing some of the stuff that we did before, like finding all 6 trig functions, but doing it in a different quadrant. Okay, so this idea of the reference angle would apply. All right, so first of all, let's look again at a definition of the reference angle. The reference angle. Number 1, I don't have it underlined because the colors are just for the picture below, but number 1, the reference angle is always going to be an acute angle. Okay? Someone remind us what an acute angle is?
Less than 90 degrees.
All right, good. It's less than 90. It's between 0 and 90 degrees, okay? Or between 0 and pi over 2. Okay, please don't ever say, oh, the reference angle is 110 degrees. Okay, because that's not acute. So we have a reference angle. It's an acute angle. And they called theta the original angle, and they're calling the reference angle here theta prime. You'll see in the diagram we'll look at in a moment. This angle is formed by the terminal side of theta and the horizontal axis. Okay? Now, one note, we're going to look at it in all 4 quadrants here. If you're dealing with an angle in the first quadrant, you're already dealing with an acute angle, right? So, in the first quadrant, the angle is its own reference angle. Okay? And by the way, that doesn't just apply to angles between 0 and 90, but let's say you had an angle of 390 degrees. Okay? You'd go all the way around the circle and then another 30 degrees. You would end up in the first quadrant. So if you are ending up in the first quadrant, you can look at what that angle would be and you can find the reference angle. That's the only time where you have to kind of think about it in the first quadrant. But you look for, in that case, the coterminal angle in the first quadrant. Well, let's look at the other 3 quadrants here. In the second quadrant, you'll notice here, here's our angle theta in standard position, so its vertex is at the origin. The initial side is the positive x-axis, and then this is the terminal side. That's why we made that red. Okay, the terminal side of our angle. The reference angle right here in green is the angle between that terminal side and the horizontal axis, or the x-axis. Okay, always go to the x-axis, never the y. Okay? And there's a little formula here, if you like that. The formula, because this horizontal axis, when you go all the way over to it, you have pi, or 180 degrees. Notice our angle is going to be short of that 180 degrees. It's going to be less than that. So you're really looking for what would the angle be that I would need to get the full 180 degrees, or the full pi? So we're subtracting the original angle from pi. Okay? So that's in the second quadrant. In the third quadrant, okay? In the third quadrant here, you'll notice our original angle here goes past pi over 2, past pi, and then it ends up down here in the third quadrant, okay? So in this case, what you're looking for when you're trying to find your reference angle is how much past pi did we go? So again, there we have subtraction, but in this case, you're taking your angle and you're subtracting the pi to figure out what this difference is. How much further did we end up going? Okay, so that's theta minus pi, or theta minus 180. And then we have our fourth quadrant. Okay, in the fourth quadrant, notice we've gone past pi over 2, pi, even 3 pi over 2, and we're actually approaching 2 pi, the full circle. Okay, so when we're finding the reference angle here, we're really finding how much would it take to complete the full circle. Okay, what angle would I need to add on here to get a full circle? So we'll take 2 pi minus theta, okay, or 360 minus theta to figure out this difference here. Okay? Now, you see here formulas for each of these. My advice to you is don't try to just memorize the formulas. Think, okay? Think about what the angle is and get like a point of reference. Get that either pi or 2 pi as your point of reference, and then it's very obvious what you need to do. Okay? I need the angle in between here. Well, this would be a 2 pi. I know this is whatever, so I've got to subtract and find out what the difference is. Okay? If you try to just memorize rules, a lot of times you're going to end up making silly mistakes. Okay? Another thing to help you is always, give yourself a quick sketch of where it is. Okay? So, what I want to do first of all here is to practice a little bit. You'll notice here we have an angle 11 pi over 6. And I have here the reference angle labeled as pi over 6. And that's because 2 pi, if I have a common denominator, would be 12 pi over 6. Okay, so 12 pi over 6 minus 11 pi over 6 is just 1 pi over 6. Okay? Let's practice with a couple others. Okay? So let's say we had an angle here. Let's start a couple in degrees. Let's say our angle right here is 160 degrees. 160 degrees. So think about it here. What would our reference angle be? 20. Okay. The reference angle we're looking for would be this angle right here, and that's 20 degrees. Okay? 180 minus 160. All right, let's try another one. Let's say we have 310 degrees. Okay, 310 degrees, we would have what as our reference angle? Okay, 50. 50, we would need 50 degrees more to get to the full 360 degrees. Okay, making sense so far?
Yeah.
Okay. All right, let's try some with radians. Let's say that we have a make sure it. Trying to get one that'll come out. Here we go. Let's say we've got a 7 pi over 5. Okay? 7 pi over 5. Think about this one for a sec.
2 pi.
Think about it for a sec. Let everyone else think about it for a sec.
That's 7 pi?
Yeah, that's 7 pi over 5.
2 pi over 5.
Alright, so you've heard a couple people say, do you agree with 2 pi over 5?
Yes.
Okay? 2 pi over 5. You think about it. This right here is pi. That's 5 pi over 5, right? It's the same thing. 5 pi over 5 is just pi. So how much further did we go? We had another 2 pi over 5. That we went.
Wouldn't it be negative?
No, it wouldn't be negative. We, when we're talking about reference angles, okay, it's always going to be an acute angle. So it's always going to be between. It's always going to be between 0 and 90. Positive angle, okay. And actually, that, you know, your question actually brings up a good point. What if I had, say, a negative angle? What if I had a negative 2 pi over 3? It would be pi over 3. If I wanted to get all the way to here, you know, what is that angle? Okay, you'd have to have a pi over 3 to get all the way over here to pi. Okay? So you can, and in fact, anytime you are dealing with any negative angles, you would want to look at the reference angle for it. Okay. But the reference angle itself will always be positive. All right, so we're getting the hang of actually finding these reference angles.
Yeah.
Pretty good.
Wait, so for that one, it would be. Oh, never mind.
This is your original angle in standard position, theta. And this would be your reference angle, using the notation we had, theta prime.
Yeah.
Okay.
I got it.
Okay. Now, the significance here, we actually looked at a little bit when we were dealing with the unit circle, when we were developing the unit circle. What's the significance of the reference angles? Okay? And here it is. If two angles have the same reference angle, then they will have either the same or opposite values of the trig functions. Okay? So, for example, if I tell you, or you know already, the sine of pi over 6, you know that from the unit circle. What is that? It's 1/2. Okay? Then that's a first quadrant angle, right? So that first quadrant angle is the reference angle. Okay? So any angle with a reference angle of pi over 6 is either going to have a sine equal to 1/2 or negative 1/2. Okay? And then that's where you use, all students take calculus to figure out, okay, am I in the first or second quadrant? Then I know sine is positive. If I am in the third or fourth quadrant, then I know sine is negative. Alright, so then you're thinking through, okay, well, what if I were trying to find the sine of a negative pi over 6? What quadrant would that put me in? The fourth. Okay, so If I'm in the fourth quadrant and I know the reference angle is pi over 6, then what's the value of sine? Negative 1/2. Good. Okay? Negative 1/2. I could do the sine of 7 pi over 6. That's from our unit circle, but 7 pi over 6, what quadrant's that in? Third. Okay, it's past pi. It's more than 1 pi. So I know the sine is negative 1/2. Okay? It's our goal as we use the unit circle to be able to come up with these pretty quickly. Okay? That's why we take the time to memorize it, and then also think in terms of that as we look to apply it with reference angles as well. Okay? Here is our unit circle. And you can see what we were just talking about as well. For example, what's the reference angle for 240 degrees? 60. Okay. Here's 240. So this angle right here is 60 degrees. So guess what? The cosine is negative 1/2. The sine is negative root 3 over 2. If you go over here to 60, the cosine was a positive 1/2 and the sine was a positive root 3 over 2. What other angles have a reference angle of 60?
150? Oh wait, no. 120, my bad.
Okay, 300 and good, 120. Okay, so here's 60 and here is 60. There's our reference angles. And notice the coordinates for all of these. You guys kind of observed this as we were developing it, that the coordinates were repeated, just the signs were different. So look at our cosines. The cosines are all either negative 1/2 or positive 1/2. And then if you looked at the signs were positive root 3 over 2 or negative root 3 over 2. Okay? And that works for every angle. If you know the reference angle, you know the value of the trig function, then you automatically know everything else. Okay? By the way, I know that the reciprocal of cosine, which is what trig function?
Secant.
Secant. I know the secant of 60 degrees is 2. So what's the secant of 120 degrees? Negative 2. Because cosine is negative in the second quadrant. And the secant of 240 degrees is negative 2. And the secant of 300 is 2. Alright? So it doesn't just work for the sines and cosines like you can see in the quadrants. It works for all 6 trig functions. Okay? Alright, so that is how we can use these reference angles. What I want to do now is practice a little bit with you, doing some various types of problems. Some types of problems we've done in the past, but it's always been in the first quadrant. So now we're going to kind of expand and deal with other quadrants. Alright, so for example, we saw some like this before. We want the values of all 6 trig functions for an angle that goes through a specific point. Okay, obviously this isn't drawn to scale, but here we have a point, -8, -15. We have the angle in standard position, theta. Okay, so in this case we're going to look at the reference angle. We'll call that theta prime right there. And the nice thing about this is we can figure out the 6 trig functions by using that reference angle as our angle that we're looking at in our right triangle trig. Okay? We do need to figure out the sides. Okay? But once we do that, we can use SOHCAHTOA. So what's the length of this side here on the triangle? Alright, -8. And notice how he kept the negative with the 8. Okay? You can either put them as positives because it's a triangle and it's a side, so it should be positive. But then you need to really think about the signs of your answer. Okay, which ones are going to be positive, which are going to be negative in the third quadrant. If you keep the negatives with the lengths of the sides, all of that will kind of be done for you. Alright, so what's the length of this side here? -15. And what's our hypotenuse?
7.
What?
I think it's 7.
No, the hypotenuse has to be the longest side, right?
17.
17. Okay, 17. This is a triple, and it might be useful for you to go back and review your Pythagorean triples if you've learned these in the past. 3, 4, 5, 5, 12, 13, 8, 15, 17, and then there's another one, 7, 24, 25. Those are the most common Pythagorean triples. Okay? It might be worth knowing, if not for this class, but also for you'll see those on the SAT or the ACT as well. Probably numerous times. So, but anyways, now that we have all three sides of our triangle, now we can figure out our 6 trig functions. So try that, okay? We have all three sides, so now come up with your sine, cosine, tangent, cosecant, secant, and cotangent. Okay. Try to write those down and we'll check it. Okay. Keep in mind our SOHCAHTOA. Sine is opposite over hypotenuse. So what's our sine? -15 over 17. Okay. Opposite the reference angle is the -15 over the hypotenuse 17. Okay. What's our cosine?
-8 over 7.
Good, -8 over 17. Adjacent over hypotenuse. Remember, adjacent means touching, so it's the one that actually is touching or part of the reference angle there. Okay? And then tangent, 15 over 8. By the way, remember when we did our all students take calculus, in the third quadrant, tangent should end up positive, right?
Yep.
And it's positive, negative divided by negative. Our sine and cosine should both end up being negative, all right? And they are. Okay? If you were doing this and you didn't like, if you don't like putting the negatives in with the 8 and the 15 when you're drawing your triangle, that's okay. Just make sure that you use this to get the correct signs for your trig functions. Okay? Alright, so now we have our reciprocal functions. Cosecant's the reciprocal of sine, so it is
-17/15.
good, -17/15. Secant is the reciprocal of cosine, so we have a -17/8. And cotangent is the reciprocal of tangent, so it's good, 8/15. Okay? So, any questions about those?
No.
Yes.
I'm just are the reciprocal functions either be bigger than sine, cosine, cosine,
Well,
oh wait.
they're not, here's the thing, cosecant and secant will always be bigger because sine and cosine, remember, are always going to be from -1 to 1. So if you're flipping a fraction, you'll end up with something bigger than 1, so they'll always be bigger. Tangent, however, its range goes from -infinity to +infinity. So, like in this case, tangent already was bigger than 1, so when we flip it, we'll get something smaller than 1. So tangent and cotangent can be anything. It's just the sine and cosecant, or sine and cosine will be less than 1. Cosecant and secant will always be bigger than 1. Okay. Good question, though. All right. I gave you some practice to do. Okay. These ones are in the PDF, but they're not listed in the independent practice. But they'd be kind of good to go back through as well. I was hoping to get to them in class, but we didn't get quite that far. But here are some others that you can practice with. So really, any of these on these last few sheets.
Bless you.
There's nothing new. It's just different ways of practicing the same concepts. Like these, it's kind of like a puzzle. Which quadrant are we in? All right. If sine and cosine are both negative, we have to be in the third quadrant. If secant is positive, what else is positive?
Sine.
Cosine. So if cosine is positive, cotangent's negative, so is tangent. So if cosine's positive, tangent's negative, we're in the fourth quadrant. Alright? Alrighty, have a great day, guys.